So what I want for us to do today is to just quickly go through the slides for Learning Unit 4. Then after that, I want us to finish off Learning Unit 3. We're just going to look at, remember I asked you guys for homework, those of you who were here, to just go through exercise 3 or should I say activity 5 in Learning Unit 3. And then thereafter, we're going to go into the task papers revision. So hopefully we can cover activity 5 and obviously the slides in the first session. Then in the second session, then we go into you guys' revision, okay, for your test. So, right. So these are the learning outcomes for your Learning Unit 4, okay? With Learning Unit 4, we're basically looking at regression and correlation. Those are the core key concepts. And then everything else that we learn about in Learning Unit 4 is just around those two key concepts of regression and correlation, okay? So let's get into it. Okay, so when it comes to regression, the key thing that we're trying to establish is there a relationship between two variables? One variable we'll call the independent variable and the other variable we'll call the dependent variable, okay? So we're trying to see, is there a relationship? Because we want to be able to predict the dependent variable, okay? So here they've given us two examples. We've got advertising expenditure, right? That's one variable, and sales volumes. So in other words, here we're trying to see, does advertising influence sales volumes, right? In the second example, or maybe before I go to the second example, basically they're saying, the more we advertise, the more we spend on advertising, is it going to increase sales volumes? Can you see that? So the independent variable is the advertising expenditure, okay? Because your sales volumes does not necessarily influence your advertising expenditure. Does that make sense? Okay, but your advertising expenditure is likely to influence your sales volumes. So that's why we call the advertising independent and the sales volumes is dependent, okay? Then next example, they've got company share price, okay? And the other variable they have is return on investment for that specific company. So if your return on that investment increases, then the share price will increase. If the company's share price increases, right, is that going to have an influence on the return on investment? Okay, so again, your company's share price, actually here it's the other way around. Your company's share price is actually the dependent, because if the return on the company increases, then the share price, the value of the company should increase, okay? So this is then your dependent, and this is then your independent, okay? Right, so that's what we are assessing with linear regression. Okay, so here it says, regression analysis and correlation analysis are two statistical methods that seek to quantify the relationship between these variables and measure the strength of these relationships, okay? With linear regression, we're saying, is there a relationship between advertising expenditure and sales volumes, okay? With correlation, we are trying to establish how strong is the relationship, okay? So that is what is happening there. And then this is obviously, you guys have seen this before, so regression is not completely new. This is your regression line. These are obviously our coordinates, okay? So basically, the first set of coordinates will obviously be your x value. So we'll be saying, okay, let's just, if we follow through with the same example of advertising expenditure, right? We would then say, because we say the x axis is always your independent, All right. So your advertising would then obviously be your X values. So if we spend 290 Rand on advertising, then we have sales volume, which is your Y values of 44 units, for example, or 44 Rand, depending on whether we're using units or Rands, okay? And we use the different data points to obviously construct our line, okay? And remember, your regression line is just an estimate. It's not going to touch on all the different data points. So each of these stars is a different data point. Okay, but I'm sure you're getting the point. And obviously this here is your formula to develop your line, all right, or to create your line, okay? The pattern of the scatter points indicates the nature of the relationship, which is represented by the straight line calculated by regression analysis, okay? Remember, I just showed you now how to make the line. Then the degree of closeness of the scattered points to the straight line is the measure of the strength of the relationship and is described as correlation analysis. So the closer these are to the line, the stronger the correlation. The more scattered those data points are, or the stars are, the weaker the relationship. Okay. All right. So like I mentioned earlier, your X values are obviously independent, okay? In this case, or in the illustration that we just spoke on, sales volume is dependent, so that's your Y, and then obviously your advertising expenditure is the independent, so that's your X values, okay? And remember, the whole focus of your linear regression is saying your independent, does it influence your dependent, okay? And they're just speaking to that there. And again, the linear regression is an estimate. Why are we doing this? So that we can try and predict our sales volume for how much advertising expenditure we put in. Does that make sense? All right. So here they're just saying a simple linear regression, there's only one independent variable. Okay, so we're only looking at simple regression, simple linear regression. However, there is actual multiple regression analysis. And there you will have more than one independent variable, okay? But here we're only focusing on just one. So don't worry about that. Okay. So here you can see already by just looking at the data points, you can tell that this is a positive relationship, positive linear relationship. Because as the X values increase, also your Y values are also increasing, okay? All right, and you can see there are small dispersions because obviously our line is going to fall somewhere in the middle of that. All right, so you can see the dispersions, in other words, the points away from that line are not that wide. Can you see that? They're not that wide. This would be wide, but you can see that it's fairly close to the line. So that's what they're highlighting there. Then here's just the opposite of that. So basically you're saying as X values increase, your Y values decrease. So that's what they mean when they say inverse linear relationship. And again, you still have small dispersions there in your values. Then here you can see your dispersions are getting wider. So the strength of the relationship is now more moderate. It's not as strong. All right. And then they're just giving you the inverse display of that as well. Here you can see there is no linear relationship because what's happening with your data points? Somebody tell me. They're all over the place. Can you see? We cannot use the X values to therefore predict the Y values. Can you see that? Because these data points are all over the place. Okay. Right. Okay, so here now they've actually just following that example of advertising weekly, number of weekly advertisements, all right, or adverts. and then units sold or flat TVs per week. So here they just putting that out on a diagram for us. It was an earlier example, but I didn't want to waste time on this because we got a lot to get through. Okay, today again, I'm just introducing this theoretically. It'll all come together when we start doing exercises together. So from here, all I want you to take away is that formula that we mentioned earlier, that's the formula we use, all right? And X is obviously the X values. In other words, the independent values, okay? B is obviously your slope, all right? And it's basically saying for every X value, Y will increase by. And then B0 is now your intercept, okay? And then Y is obviously the dependent variable, okay? That's the variable that we're trying to predict for. So we can tell what value your dependent variable should be if we have all the other pieces of information, okay? Right. So here you can see we have this thing called the error term, okay? And it's basically your dispersions. So we predicted, all right, or forecasted or estimated the nature of the relationship. But you see here, that's why we have y hat. Can you see that? Y hat 1, all right? That's an estimation. That's why we have the hat there. But y1 might actually be all the way over here where the star is. Can you see that? So can you see there's a dispersion from what we've estimated, right? And what y actually is. All right? So therefore, this is why we call this the error. All right? Or the standard error. Okay? But again, we'll look at these in more detail through examples. And then here they're showing you how you can calculate your gradient and then obviously your intercept. Okay? Right. Okay. So here now they're estimating your y values. It's an example on how they're estimating. And this is what I was talking about. If you want to calculate your standard error, all right, there's your formula there. Okay. Yes, yes. What's happening? No, you know why I'm doing this. Remember, I'm just introducing concepts. We're going to delve into these things, break them down when we're looking at formulas and actually answering questions. And remember, the other reason why I'm also rushing, I know I'm rushing, but the reason why I'm doing that is because today we want to revise, isn't it? So in the first session, I want to cover these slides, and then I want to, after covering the slides, I want to just go through one or two exercises, finish off the video today, and then we get into the revision for your testing. But this is also being recorded as well. And in your test week, what I'm going to do is that it's just that now I don't have time. I'm also going to refer some YouTube statistical videos that you guys can go over, just so that you get this stuff from a conceptual standpoint. So some additional videos that you can look at to explain these things, all right? And then I think that will definitely drive the point home. But guys, I want to reiterate, don't waste so much time reading the slides and reading the textbook. This stuff is just for us to conceptually get a gist of what's happening. So the key things you should have taken away by now is what is linear regression. It's a statistical method that we use to establish, is there a relationship between two variables, of which one variable is independent and one is dependent. The dependent is the one we're trying to predict. All right, going back to our first illustration, we have advertising. All right, advertising is the independent, okay? Because our sales volume does not influence advertising, but advertising can influence the volume of sales that we have in the business, okay? Then we spoke to the strength of the relationship. How strongly does advertising influence your sales volume? and we analyze that via correlation. We haven't yet gotten to correlation and the calculation or the formula for that, but those are just the key things that I want you to take away, right? High level. I don't want you understanding everything now, okay? Does that make sense? Are you a little bit more at ease? You guys, I promise you this, with numeracy, you will not understand everything at first glance. It's to practice, practice, practice. So don't panic, don't stress, okay? Don't stress. All right, I'll try move a little bit slower, okay? All right, we already spoke to B1 being the gradient, all right? Basically highlighting that for every change in X, Y is going to change by this much, okay? Right. All right, so extrapolation, we're looking at extrapolation, right? I want to look at a data set to explain this. So here, if you look, we have all of the number of ads, right? And then we have all of the Y values, right? So basically, we calculated to say, when we have 4 adverts, we get 26 sales, right? Can you see that in the first row? Ah, sorry. Okay. Okay. Yeah. When we have 4 adverts, we have 26 sales. When we have 5, in this particular period or time frame, we had 37. When we had 3, we had 30. Okay. So there you can see all of the values that we have for our data. Sometimes when making an estimation, which is what they're trying to talk to here, we might say, let's use number, let's say 20 adverts, all right? That 20 adverts was not in the data. Can you see that? So since it was not in the data, we now are calling this extrapolation because we're now estimating the Y variable or the dependent variable without the independent variable actually being part of our data. So here, all that they're highlighting is they're warning us that if the X values lie outside of the domain of our data, the Y values are unreliable and possibly even invalid. That's all this slide is pretty much trying to tell us, okay? Right, then here now we're talking about correlation. Remember we said the core key concepts, regression and correlation. So correlation, like I explained earlier, is showing the strength of the relationship. Linear regression, is there a relationship? So what are they saying here? The reliability of the estimate of Y depends on the strength of the relationship between X and Y variables, okay? Correlation analysis measures the strength of the linear association between 2 numeric variables. All right. So that's the core of what you need to take away there. Then this is just the formula, okay, which we will dissect and get into when we start doing exercises together. And there's just an example, okay? So here, I can actually explain it via this graph. When you're talking about correlation, right, the correlation will fall between these 2 variables, -1 and +1, okay? Now, if something is either -1 or +1, there's a very strong relationship, okay? Whether it's negative or positive, as long as it's 1, there's a very strong relationship, okay? When we get closer to 0 from either side, the relationship is becoming weaker and weaker, right? Basically, we're saying here, at this end, we're saying that for every increase in Y, in the X variable, the Y will increase at the same at the same measure, so almost to speak, okay? And likewise, we're just saying negative, meaning that they'll move in opposite directions, okay? So every positive increase in x, y will move in a negative manner, okay? But otherwise, there's a very strong relationship, all right? Which again speaks to the reliability with which we can use our independent variable to predict our dependent variable. So we want a strong correlation. Does that make sense? And I would say from 0.8, whether positive or negative, to 1 is a strong relationship. Okay? Is a strong relationship. Okay. Then from 0.3 on either end to 0 is a weak relationship. Therefore, from 0.4 to 0.7, you can call that moderate. Okay? All right. Anyway, so here you can you see this line? All of the values are falling on the line. Can you see that? This you can see, like we said, this is obviously a positive linear regression, okay? And here that means your R, in other words, your correlation is a positive 1, okay? Can you see? So now you can see that for any of your values here is going to increase likewise for your Y values, okay? And you can see our relationship is very strong because it's all falling on the line, okay? I'm going to skip through some of these. This is just the negative, but it's exactly the same. All of the data points are falling on the line. So a very strong relationship. It's just that it's a perfectly negative linear correlation or relationship. Okay. So here you still got a strong association, but you can see that the correlation is not 100% positive 1. Okay. But it's going to be close to 1. And here, exactly the same thing, just showing you in a negative correlation standpoint. And here, can you see what I was saying? The more scattered the data points, the weaker the relationship. Is it making more sense now? Okay, and there they're just showing you, again, from a negative standpoint. Again, this is, the relationship is getting weaker. And here you can see, again, no association. Just like we said, here there's no linear relationship, all right? Right? There's no relationship there, okay? Because the data points are all over the show. In other words, the values of x are of no value in estimating the values of y. Remember, we're doing this so we can predict the dependent variables. Since the data points are randomly scattered, which is what we have just highlighted. Okay, all right. Okay, so here they're just highlighting that a low correlation doesn't mean there's not a relationship. Only that the relationship is poorly described by a straight line, okay? There might be a non-linear relationship, okay? Remember, when we're talking linear regression, we're always talking about a linear relationship, but there might be a non-linear. Okay, correlation. A correlation does not imply a cause and effect relationship. It is merely an observed statistical association. Okay, right. Okay. We can leave this for now. Okay, the R squared coefficient. Okay, here I'm just going to explain this. We want to know to what degree does your X variable, in other words, your independent variable, actually explain your dependent variable. That's what you're measuring with your coefficient of determination, okay? You're trying to explain how much does the independent variable explain your dependent variable, okay? And therefore, you can always explain it from 0 to 1, okay? But I prefer to go with percentages because we already mentally, proportions are easy for us to get a feel for how significant something is by means of percentage. So for instance, if I say there's an 80% coefficient of determination. We're basically saying 80% of y is predicted by the x variable. Okay, all right. Okay, and then there they're just explaining it graphically. So here, if you get 0, it means there's no explanation. All right. Here, if you get 100, then it means it's explaining completely the variation in your y variable. All right, your dependent variable. All right. So again, here we're looking at the strength of the association, but here now we're talking about how much does the dependent, sorry, yes, the dependent get explained by the independent. Okay. Okay, so here you can say proportion. You can see they said proportion of explained variation in y due to x. Okay, right. Cool. So this again, they're just giving you an example. And that's your learning unit 4 from a theoretical standpoint. Again, this is something we're going to dissect and go bit by bit as we go through questions. Remember, this is not a theoretical module, okay? But I have to do this so you have an overview, okay? So that you have an overview of what we're doing. Okay, and another way to quickly pick out what is important in this learning unit, formula sheet. Look at the formulas that they give you. The formulas they give you, those are the key things they want you to take out of that learning unit, because those are the things they're going to examine you on. Does that make sense? Okay, all right. Okay, cool. So now